Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is the specimen paper for 9231 Pure Mathematics 1 for the 2020 exam series, question 3. The curve C has polar equation r equals 2 plus 2 cosine theta for 0 to pi. Requirement A, sketch C. I've included a coordinate plane. I'll label the horizontal axis as theta equals 0. And the vertical axis as theta equals pi over 2. I'll then set up a table. My input is theta, and my output is r. So I want to generate several values to then plot the points to create the curve. When theta is 0, r, the resulting output is 4. For pi over 4, the result is 3.41. For pi over 2, the result is 2. 3 pi over 4 produces 0.586, and pi produces 0. Now I'll plot these 5 points. I'm going to create a dotted line to indicate the pi over 4 value, not required but helps me with my accuracy, as well as the 3 pi over 4 value. I'll also mark off 2 and 4, 2 and 4, 2 negative, and negative 4. And now plotting my points, where theta is 0, that's the horizontal axis, r equals 4. Theta pi over 4, the value is 3.41. That's going to be about here. Pi over 2, the output is 2. 3 pi over 4, 0.586. And at pi, we have 0. Now I'll draw in my curve. And this is my result. That completes the requirements for part A. Let's move on to part B. Find the area of the region enclosed by C and the initial line. The formula for area, working with polar curves, area equals 1/2 times the integral from alpha to beta of r squared with respect to theta. In our scenario, we're working with 1/2 times the limits 0 to pi using the function 2 plus 2 cosine theta, squaring that function with respect to theta. Expanding, we have 1/2 of the integral from 0 to pi, 4 plus 8 cosine theta plus 4 cosine theta squared with respect to theta. I'm going to use a trigonometric identity to replace the quadratic term for cosine theta squared with a linear term using the identity from the formula booklet and some algebra. This becomes 2 cosine 2 theta plus 2. I'll perform my integration to get to 1/2 times 6 theta plus 8 sine theta plus sine 2 theta from 0 to pi. And here, completing the inputs of pi and 0, subtracting the two results and remembering to multiply by 1/2, I arrive at the value of 3 pi. This completes the requirements for B. Let's go on to part C. Show that the Cartesian equation of C can be expressed as 4 times quantity x squared plus y squared equals quantity x squared plus y squared minus 2x squared. To go from polar form to Cartesian form, three important relationships I want to remember. X equals r times cosine theta. Y equals r times sine theta. And x squared plus y squared equals r squared. I see I've left out the squared in making the video. That was an oversight. I'll add that back in just a moment. Starting with our polar equation, r equals 2 plus 2 cosine theta. Now I want to go from r to r squared. There are two ways I can do that. I can either multiply both sides of the equation by r, or I can square both sides of the equation. In this case, what I want to do, and if I don't know, through trial and error, I'll figure out that what I want to do is multiply both sides by r. The result, r squared, is 2r plus 2r cosine theta. Now looking at my relationships on the left side, I see I can replace r squared with x squared plus y squared equals, for now I'll leave 2r as is, plus 2 times, again a relationship I have for r cosine theta, this equals x. Now looking up at my requirement, I can see one side of the equation has the terms x squared, y squared, and negative 2x. I can work towards that grouping by moving the 2x. So on the left I have x squared plus y squared minus 2x, subtracting 2x from both sides, equals 2r. Now I mentioned a moment ago that I left out the squared in that third relationship on the left. Let me write that in. Looking at my requirement, I see one side of the equation has the expression x squared plus y squared. I know from my relationships on the left that x squared plus y squared equals r squared. I see in my equation as it stands on the right side there's an r. I want to change that r to r squared, and then I'll substitute in x squared plus y squared. I mentioned earlier I can get from r to r squared by multiplying by r or by squaring both sides. That's what I want to do now. When I square both sides, I end up with x squared plus y squared minus 2x squared equals 2r squared. This simplifies to x squared plus y squared minus 2x squared equals 4, which is 2 squared, times r squared. And now I'm going to replace the r squared with x squared plus y squared. And I'll switch the sides to put it in the same order as the requirements. 4 times x squared plus y squared equals x squared plus y squared minus 2x squared. This completes the requirements for part C, which completes the requirements for question 3.